Hi, today we're going to start a 2-day lesson about getting the quote-unquote best fit line for a data set. And today we're going to use the table that you see here that gives the median heights for boys aged from 2 to 7. The first thing, our first job is to make a scatter plot, and you know when we do this by hand that's going to be a little bit of a guesstimation, but that's okay. According to the table, 2 years old, 35.8, so maybe in there somewhere. 3 years old, 39.1, so maybe perhaps up in there. 4, 41.44. 5, 44.2 approximately. 6, 46.8, almost up to the 47. 7 years old, 49.6. Oh, little growth spurt there it looks like, and that data is fairly linear. What we've done before in our algebra classes are pick 2 points from a data set to come up with an equation for the line, and that's exactly what we're going to do here. I'm going to ask you to use the first data point, 2 and 35.8, along with the last, which is what many of us would have selected anyway. You know, you can pick any 2 points in here will generate a linear equation for you, so it's up to you the 2 that you pick. So you want to pick 2 that you think are going to show the trend, and that's a pretty good fit, I would think. So as we do this, in order to find a line, we have to know a slope. I'll remind you that the formula for slope says you subtract the 2 y values from your points over the difference between the 2 x's. Once we have a slope, we're going to put that into the point slope form of a linear equation, which you will also recall from your algebra classes. Y minus y1 equals slope times x minus x1. So let's go ahead and find the slope of our line. We need to subtract the 2 y's, so 49.6 minus 35.8. and that's over the difference in years associated with those points, so 7 minus 2. I want to get my calculator up here, I think, because we're going to do a little arithmetic. So 49.6 minus 35.8, all divided by 5. I can do that part in my head. The slope of our line is 2.76 inches per year. All right, that's what the slope is telling us. The number of inches that a boy grows in this particular scenario per year. So almost 3 inches per year. To find the equation of our line, we're going to substitute either the first point or the last. It doesn't matter which. I'm going to use the first one. Y minus 35.8 equals the slope that we generated, 2.76, times x minus the x from the point, which is 2. To simplify this, you're going to do a little bit of distribution, and I'm going to do that up here so that I can see what I'm doing and not clutter my screen down here. Y minus 35.8 will equal 2.76x minus, and 2.76 times 2, which I should probably be able to do in my head, but I reach for the calculator because it's there, minus 5.52. Now I want to add that 35.8 to each side. Here comes my final equation. Y will equal 2.76x plus, because we're going to add or subtract from that, so we want 30.28 inches. All right, and there's our linear equation. It says that we should add it to our plot. All right, there's how that line fits the data. We got the first and second, but you can see we did not hit any other points. That could just be because of the way I plotted those points, but we're pretty close to all of them. So thank you, calculator. That was nice, and line drawing tool. That was nice as well. All right, there are a couple of reasons why we'd be interested in having a line that fits a scatter plot. Number one, it provides a summary or mathematical model, if you will, that describes the relationship between the 2 variables. In our case, that relationship was 2.76 times age plus 30.28 inches should give us the height of a boy between the ages, say, of 2 and 7, since that's what we use to generate our data. That brings us to the second big reason why we would be interested in fitting a plot to a line. Once we have that model, we can use it, folks, to predict values of y for given values of x. The x variable is called the independent. You'll remember that from your algebra classes. Independent, or here's a more statistical definition of that, explanatory variable. If you think about that whole idea of cause and effect, what we're saying is that the x is what explains change in the y. The y is called the dependent or response variable. Again, those two definitions, or those two terms, explanatory variable, response variable, those are very much statistical in nature, saying that changes in the explanatory variable create change in the response variable. We're to use our equation. It says to predict the median height for a boy who's 4.5 years old. Well, that would just mean using our equation with an x, or a boy's age, of 4.5 years old. So doing that arithmetic, 2.76 times 4.5 plus 30.28, our line would predict a height of about 42.7 inches for this child. All right, making a prediction like that when the x falls inside the range of data, and in our case that range was 2 to 7 years, that's called interpolating. That's generally a safe thing to do. However, if you're trying to make a prediction when your x value lies outside of the range of your data, that's called extrapolating. That can create some problems. If you do that, folks, say if we were going to use our line to predict the height of somebody who's, say, how about 25 years old? Okay, do we have any guarantee that we're going to continue to grow at a continuous rate of 2.76 inches per year? Probably not. Making predictions when the value of x is outside the range of the data, that can be a little iffy. You certainly can do it, but you can't guarantee the accurateness of those predictions if you go outside of the given range of data. We don't always know whether or not predictions we make based on a line will be exact, but we hope that they won't be too far off. The prediction error, again, that is exactly what you think it is. We don't want that to be big. The idea is we want to make good and accurate predictions. The prediction error, there's another word for that, term for that, the residual, is found by subtracting an actual y minus a predicted y. So if you think about that, if our line is a good fit, the difference or the residual should be very small. We want small residuals. Graphically, the residual is a vertical distance. It could be either positive or negative between the actual data point and the y value that the line would produce for that particular value of x. It says that we should sketch in the residuals for each of the data points in our plot. And that means we have to go back to our plot. So let me get back there. And for each of our x's, we want to find a residual. So we're going to use the equation to generate a predicted y for each. Now I'm going to use my calculator to do that. And I already have put my actual ages and actual data values here. In my third list, I'm going to create a list of predicted y values. That is, I'm going to put my equation up there, 2.76 times x. Here are my x's. So list 1 plus 30.28 inches. When I hit enter here, we'll get a predicted y value for each age. And notice our first and last are perfect. They should be, because those are the ones that we generated to find our lines equation. What I would love to have you do is think about making, or what that question asked us to do, is draw in the vertical distance between each point and what the line would predict at that point. So we have no vertical line first or last because those were exact, but at 3 years old, the line predicted 38.5 and 38, we're pretty close, but the residual would be, folks, that distance, the vertical distance between the point and the line, and all of these were just a tiny bit under. All right, each of our points was a little bit lower than what the line predicted. In fact, you can verify that here. In each case, we were lower than what the line predicted there. So we missed those 4 points exactly each time. All right, let's go back and finish out our discussion here. A good best fit line, folks, will minimize the residual. That is the difference between what actually happens and what should happen. Should be very small. That would mean that our line is as close as we can get it to all the possible data points. That wraps up our discussion for today. We're going to ask you to get out there and think about that U-try as quickly as you can, and hope that you have a wonderful evening.